So do you have like questions specifically?
Yeah. So the main goal, I guess, I want for this meeting is like a couple things. First thing, like we don't know a ton about kind of just like the suspension fundamentals yet. Like we've been trying to learn a lot about it. I'm not sure if we're going in the right direction yet. I think we are, but I'm curious like what resources you guys use to like learn about that stuff and like how you guys got to where you are in terms of like technical knowledge. And then number two, how do you guys structure your like, design cycle? Like what do you start with, I guess, and like what are the steps you take? And also if there's anything that we can help you guys with, you know, because, yeah, I really appreciate you guys like putting the time aside to like talk to us and help us because we have a lot of things to learn. So, yeah, but the first thing I wanted to do was I want you guys to like test us on like suspension stuff.
Oh boy.
And
oh no.
like, yeah, you guys test us and like gauge where we are, and if you guys, and then like, yeah, maybe you guys can tell us what you think we need to like improve.
Yeah.
Just ask us like random stuff. Yeah.
I guess like beforehand, something I want to like mention is like suspension feels like a huge rabbit hole where like nothing makes sense and like it all just feels made up. And then like all the information online, like everyone's like really pretentious about it.
Oh really?
Like they'll just explain things in like the way that makes the least amount of sense,
And
then you feel like,
do it
wow,
that way.
so smart. Yeah.
Yeah.
So I don't know. I don't know. Suspension the whole. I don't know.
Okay. We'll try our best.
Okay. I guess. Are y'all familiar with like roll centers?
Yeah.
Okay.
Like I know how to find it. I know what it means. It means like it's the point where the car rolls about.
Yeah. What's
And
up?
it's like the CG rotates about it. So if it's on the CG, then it technically is like no roll.
Yeah. So then, how did y'all design around it this year?
How did we design around
Or
it?
I guess I'll go back.
Uh-huh.
What's like the significance of it? Like,
The significance?
why would
Well,
you want it?
Why would you want to have roll or like have?
Like, I guess what's the positives of having like a higher roll center? What were like the drawbacks of a higher roll center?
You guys know?
A higher roll center? So if your roll center is above your center,
There's 40 possibilities of movies.
your corner is. Or I guess an easy way to think about it is your center of gravity will never surpass your roll center.
In fact, there's only 6 questions.
I guess, like intuitively, you wouldn't want your center to be below your center of gravity.
My understanding is it's all like relative to center of gravity. So like, and usually it's below center of gravity. So if we assume it's below CG, then like the lower it is, then like the more like likely your car's to roll, but like for like the same amount of like bumps that it goes over and stuff like that, or like turning, and like yeah, the less it'll roll.
Yeah. I think one like really good way that I like to think about it is like you said, everything's like proportional to your CG. So like, roll center on the ground is equivalent to like 100% roll. If your roll center is like 50% between like the ground and your CG, you're gonna like reduce your roll by like 50%. So yeah, essentially like the whole thing is like just reducing roll. So then the question is like, why does roll matter? Like, why do you care about that? I'm gonna be honest, I don't really know this answer.
Well, it's bad because like it if you roll, the more you roll, like the more momentum you lose. I think that's one thing. And so it's like, you know, if you're turning like, and all your mass is like rolling like super far outwards, then like once you've come out of the turn, like and you try to accelerate, like a lot of your mass is still trying to go one way, but your car's trying to go like another way. Like that's one thing. And also, I'd assume it like, I think it might have to do with like contact patch as well. I'm not sure. Like it could reduce your contact patch, but not sure about that.
Yeah. So your first point, this fucks with me. Your first point, it's actually not true. Like,
Oh, really?
no matter what your roll centers are, like, okay, let's say like you have both. You have two cars, one where your roll center is like on the ground for both like the front and rear, and then one where you have both of your roll centers at like your CG.
Sure.
You're gonna get the same amount of weight transfer or like the same amount of momentum no matter what. So like,
Oh, okay.
you're gonna have the same like momentum or like
I
same
see.
weight transfer, which is like the big thing.
Okay.
Lateral load transfer. Yeah. What does change though is like, let's say your roll centers are like different heights between your front and your rear.
Yeah.
That's what would change like your lateral load transfer.
Oh, so it's the angle of the row axis, basically.
Yeah. So then like higher roll center in the front means more weight transfer. Or wait,
Left weight.
God, I haven't done this in a while.
Yeah, I know, it's been a while for me too. Right.
Um,
Higher CG, or higher relative CG is less.
It should be more weight transfer because it takes more force to roll your front of the car the same amount as the rear of your car.
But generally, like most cars have a lower front roll center, right?
Yeah. And do you know why that is?
No.
Okay. This isn't. I can't really like understand it like thinking through it logically, but like higher roll center means you get like faster weight transfer. And so if you're like imagining how your car works, like you're steering with your front tires. Are y'all familiar with like slip angle and all of that?
Yeah, I know slip
Yeah,
angle.
slip angle.
Slip angle is like when your tire is like turned, let's say, and like your car is like, let's say your car is turning, right? Your tire turns first, so there's gonna be a point where like your car's still going in one direction, but your tire's gonna go in another direction, and so like depending on the flexibility of your tire, like the contact patch is gonna like deform a bit. It's not gonna stay straight. It's gonna be like a zigzag, for example, right? Like the tire's turned this way, but the point where it's contacting the ground is still pointing where the car is currently going, and so the difference between like where it's pointed and where the car is going is like slip angle. Is that right?
Yeah, right here.
Yeah, and if you imagine like your tire is essentially a spring. Everything's a spring. So if your tire is trying to like deform, or if your vehicle is heading like this way and your tire is pointing this way, it's trying to deform your tire. And since it's a spring, any deformation creates like a force. And so like from your tire deformation, you get lateral force. So in like a less convoluted way, essentially deforming your tire makes you turn. So I guess going back to what I was talking about, if you imagine like during a turn, you're steering your wheels like creates a slipping on your tire. So then the front of your car starts to rotate because your front of your like car is generating that lateral force from a slip angle. So then your front of your car starts turning, but you have like a non-zero amount of time between like the front of your car turning and like the rear of your car rotating. So that you kind of want a higher roll center in the rear, so that you get faster weight transfer, so that your rear can catch up with your front.
Oh, okay. That makes sense.
Yeah.
That makes sense.
Cool.
I don't know how you like pick how much. That's I don't know. I don't know how to do that.
Yeah, but it's generally why it's like higher in the rear.
Yeah.
Okay.
Yeah.
And also like just a premise.
That's for cute.
We didn't do we none of us really know much about
And you just go from there.
the current design of our current car.
Once you start going to the second,
I've only been suspension made since like last August, and most of the design was done like 2022 fall.
Yeah.
So,
Like, wide.
yeah, but we've been trying to like ask like Jake out of it, Philip, a lot about it, but like they know most of it.
What is the status of? So Jacob is chiefy. And then
Jacob's CP,
Philip
Philip
is-
is Dynamics lead,
Okay.
and then you know Nathan Lee.
Oh, another face.
He's our mechanical lead, but like the three of them are the ones that know like, pretty much everything about like dynamics. So, yeah. Any other questions you want to touch us on?
No,
Or-
exactly determinate means
Oversteer
when
and
the thing. I got
understeer.
you.
Are y'all
I remember.
familiar?
Exactly determinate means it's
Yeah.
everything equals zero. Remember that?
So
Like everything is an equilibrium.
Actually, no.
Exactly
I want to
determinate
ask y'all
means
about this first.
You're calculating.
Do you know how y'all like quantify your suspension stiffness? Like how do you do y'all have any like spreadsheet or some way to like figure out like, oh, if we have like this motion ratio and this like spring rate, how stiff that would make our suspension?
Like effective spring rate, basically.
Yeah.
We don't currently have any data on that for our current card. Like we have very little data to work on. Like we don't have any data from our previous card. First of all,
Yeah.
we collected zero data, so we're starting from like nothing. And and also a lot of the suspension design for this current car was like there was not a lot of that done either. But like we tried to like a lot of it was just like make something that will work.
Yeah.
Like given like you know like this track with this like shell with this frame size, like yeah, it was very little like optimization stuff.
Yeah.
But wait, what was your question?
I was just like wondering if y'all had any like a way to quantify your.
Oh, the stiffness. Yeah. So, I think how you would do it is like you have like a target like bounce frequency, I guess, and then like you can kind of work backwards from that to like calculate. Okay, if I want this bounce frequency, then I want like this effective spring rate, and then like you know I like and the things that make up this effective spring rate include like my shock or like spring stiffness. I know you guys looked at like your like hardware stack compliance, which is like very small. So I don't think it matters a ton, but you also got to factor in like your tire stiffness and I think that's mostly it.
Yeah, that's the main thing. Is then like the motion ratio.
Okay.
Do y'all know like I mean when I say motion ratio?
Like wheel to shock travel ratio, right? Yeah.
So something that is like, in my opinion, it's like really good on like resource is like race car vehicle dynamics by Millikan.
The book.
Yeah.
Yeah.
And on like
Zero, I
Trapper.
interpret as not to be.
Here, let me create like a little quick Slack chat.
Okay.
But like there's a chapter where it like goes into like all the calculations and it just like walks you through everything. It's I don't know I found it is like one of the most useful things you can find on Slack. Okay.
Yeah, I read this one book. I actually have it on me. This is like specifically for like solar cars.
Yeah.
And it's like a similar thing.
Well, it's just it goes to.
But I think race car vehicle dynamics probably goes into more detail. Yeah.
Like here, I'll send you.
Another point is to like when we're talking about roll, in regards to like roll centers and things like that. another reason why roll is bad is you don't want stuff to scrape. So like in our case, it's like front wing, under tray. In y'all's case, I guess it'd just be body work.
Yeah.
So you don't want to be scraping all the time. If you have a lot of roll, then the sides would scrape.
Yeah, like you're converting properly engines and
Let me know if those, that link doesn't go.
Where is this? Oh.
It's yeah.
Oh,
That's,
yeah.
And then another thing that might be useful. It's a little more specific to like FSAE rather than solar car, but I don't know. I compiled like a bunch of resources that I kind of used to.
What's the importance of motion ratio in terms of like that effective stiffness stuff?
Yeah.
it's just zero.
Ooh, this is a fun question. Do you know what I'm looking for?
Maybe. Oh my gosh.
Okay, Kadir, I think you've seen this picture.
I have, yeah.
Okay, so imagine you have like this like little system. It's like you have this pivot over here. You have a wheel at the end of this like bar, and then a spring somewhere on that bar. So if you have like your spring closer or further, like how do you think you could make this like system stiffer by moving the spring?
Move it closer to the pivot point, like to the right.
You think so?
I think so.
So I guess if you think of everything in terms like a torque,
Yeah.
how do you make the spring produce like a higher torque?
Because this is like a trailing arm, right? So it's like this whole thing is like rotating about this point.
Yeah.
Right. So.
It's just
Move the spring closer.
you still got to know the right way.
Yeah.
And then
And why would that be?
probably should let
Because
know what's going on.
the force on the spring is a torque, and torque is dependent on radius. So the smaller the radius,
Exactly, you can't get an injury check.
or the smaller the radius. But I guess the difference between the radius in this case.
Kind of, yeah.
So you want like the radius in your case is kind of like the distance between your pivot point and the location of the spring, right?
Yeah.
Which is indicated by A, I think it says.
The larger the radius.
Yeah, so the larger the radius,
More-
yeah,
Yeah.
force times distance. So more distance, because your force is constant, more distance closer to here is stiffer.
Yeah. And then the thing that I think is like more important for like our or like easier to understand for like our applications are like if you move the spring further from the pivot, is it gonna compress more? Like, okay, let's say you move the wheel by like 1 inch. If you moved or like push the wheel up by like 1 inch, if you move the spring more outwards, would your spring compress more or less than if it was like inwards?
I think it would compress more.
Yeah. And then, like, if F equals kx, then,
Yeah.
like, compressing the spring more means that you're going to get more of, like, a resistive force because
Yeah.
of... So, like, moving it outwards has, like, two effects. It both, like, compresses the spring more and makes the spring produce, like, a higher torque. So, it's kind of like... if you imagine like moving your spring outwards has like a squared like effect where it's like if you move it out by like 2 times, then you're increasing your stiffness by like 2 squared.
Okay.
God, where was I going with that?
Motion ratios?
Oh yeah. So effectively, if you
Yeah.
bring that into like our cars,
Yeah.
if your spring, if you had your spring like compressed by half the amount of your wheel versus if you had your spring compressed like the same amount of your wheel, then the one where it's the same amount of your wheel will be like 4 times stiffer
Yeah.
than if it only compressed by half. Because now you're compressing the spring by twice the amount, and then you're also getting like twice the amount of leverage.
So by varying, so to bring it home, by varying your motion ratio, you can vary the amount of stiffness of your shock
Okay.
to hit whatever you need to hit.
That makes sense.
And like,
Cool.
at least we designed our motion ratios all around like that calculator, like the Millikan that one chapter, chapter 16. That's pretty much how we did our motion ratio is like you mentioned, we had like a goal in mind of like a
Frequency.
yeah, and then
Was it like bounce? Or did you like
it's-
decouple it?
we can't.
Oh, okay.
But we did essentially bounce. We're like they call it ride frequency.
So I have a follow-up question on this. So is your motion ratio like linear, like always the same for all?
Ideally,
Yeah. Do y'all run bell cranks or?
Yeah.
On the front.
Okay. Yeah.
is
Oh,
the back direct back?
Yeah.
Okay. I mean, we tried. In reality, it's hard to, but we're within like, I think our range is like, so our goal was like 1.1 for our motion ratio. We were between like 1.1 and like 1.15.
Okay. I don't think ours is linear. Like,
Or motion ratio?
yeah, just because of the way the belt crank is designed.
Yeah, I could be. I'm not sure.
And do you know like the benefits of having a dynamic motion ratio?
I think one case would be if you have like aero, because like the faster you're going with aero, the more like downforce you're gonna be producing. So let's say you're going really fast. Maybe you would want a motion ratio where with more travel you get stiffer, so that like you don't end up bottoming your suspension out when you're going really fast.
Okay, that makes sense.
That would be one case. And like in that same case, like the benefit of having it being dynamic is like when you're going like at a slow speed, then you can still go over bumps and like still have that soft suspension.
Optimum contact package, like contact duration.
Yeah.
Yeah.
So if that's the case, why do you guys go for
It's largely because like it's hard to prove how dynamic you want it to be. Like it's hard to quantify like what's the perfect amount of like progressiveness that you can get. Like, and then another reason is like whenever you're actually like assembling your car, it's hard. Like it kind of just makes it more complicated to like, let's say you're trying to like set your ride height. Or like set something, and you want to set it like let's say you want your car to be like exactly 3 inches. If you have like a linear motion ratio, you could just quickly do the math like, oh, we just have to do this much spring compression to change the height of the car. Whereas like if you have like progressive,
It saves time on calculations.
which is
Okay.
but it would be really cool if
Like
you could like figure out like, oh, this is like the most
Quantify or justify
It's
it.
not a-
Yeah.
Linear or not linear.
Okay. Cool. All right, let's do like one more question and then we'll move on to like other stuff. Give us like a really hard one, like something that you think we definitely don't know.
Something about tires. Something we can't even answer about tires. I mean, like, there's not much.
honestly, roll center is like one of those points where I'm like, it's like one of those things where like it's kind of as hard as it gets. Or well, no. But okay.
Maybe like a big picture.
Why? This is like
He's never saying Regina John.
why does suspension matter?
Yeah.
Because the goal is to minimize like how much energy you're losing, like from all the bumps and stuff.
Like he doesn't.
At least for solar car, it's like literally just like energy efficiency. And so my understanding is it largely comes down to like tire alignment and also like scrub. Those are like two main factors that go into it. And so like, and also like driver comfort obviously. But yeah, like you want suspension to be able to like absorb energy from going over bumps and like minimize energy loss.
Can you quantify like when you say energy? Can you quantify like in a more mechanical way? Like what maybe
Um,
like what really?
Yeah, so there's
She doesn't have one.
like for like us, I guess you have like the kinetic energy of the car like traveling forward, right? And when you go over a bump, like some of that kinetic energy is lost because the bump like like let's say
It's basically like going up a small ramp. Like some of the
Yeah.
kinetic energy goes.
it transfers to like potential energy in your spring when it compresses. Just like the shock releases it as like heat, and you lose a lot of energy to like friction from like rolling resistance and stuff like that too, I guess. So yeah, like friction.
Okay.
And
So then,
vibration also
Yeah.
takes up energy. Like if you're driving on like any road without like if it's not like a perfectly flat surface and you're driving without suspension, you're gonna have problems with like vibration, which is lost energy.
So then, how do you deal with vibration with this? Because like the spring doesn't do anything for vibration. It makes it worse if anything.
The shock, the damper.
Yeah. And then, do you think there's like a way to calculate like what's the optimal amount of damping?
Damping.
Or like I guess that's not really a great like recommended push, but like I mean there's like calculations for like we haven't done it. It's kind of over my head.
I
But
know it's
like,
proportional to like velocity.
yeah.
Yeah.
And then you can design around like what's the most expected cost. That's what we lost. I guess going back a little, you said kinetic energy.
Yeah.
What can you go through like the whole process of like where you're creating that kinetic energy? Like starting with like your powertrain.
Powertrain. Okay. Powertrain. The motor sends electrical energy to like the wheel, right? And then like whatever, or the motor converts like electrical to mechanical energy, and then like so you have that mechanical energy, like wheel rotates, turns into like kinetic energy of the car moving forward.
How does your wheel rotating create kinetic energy?
Because it has like grip on the ground, like it grips the ground.
What is grip?
The tire.
Yeah.
Okay. And like static friction pushes the wheel forward.
Okay, so static friction is the point.
Yeah.
Yeah.
But it creates like the torque from the motor, I guess, translates into like a forward like driving force, like driven by like friction, I guess, between the tire and the ground. And so you have like a force going forward, and then like kinetic energy is like force times distance, right? So you could, or you could do like 1/2 mv squared too. So like, yeah, and then when you go over like a bump, you
Our hardest class in our semester is
like
So this is like while the car's parked, like with suspension or without?
Let's do imagine a car without suspension.
Okay.
What happened?
after that which
without suspension going over a bump. What would happen is you like I think like your some of the velocity goes from like being like purely forward to like some vertical,
Yeah.
I guess, right? And like
have you seen the film?
because you like energy is conserved, like the like forward component of velocity is like reduced. Like,
Why is it reduced? Because again, let's go back again. What's producing that forward velocity? There's like one thing that I'm gonna like pound on.
something I'm missing.
Like, no, you said it already, but there's like one part of the car that's generating like
It's a key component.
the motor.
yeah, or like it's like a more mechanical.
Friction.
Yeah,
Yeah.
And what creates the or like what
The tires.
Yeah.
Yeah.
Tires.
So like
So the tires are the key component. So it all surrounds the tire. So
Uh-huh.
the tire does what to generate forward velocity?
Rotates.
Via and then
Via
pushes
static
via
friction.
friction, right?
Okay.
So focus on that.
Get TS
Okay,
clearance.
in a bump, if you have like
Yeah.
up.
Okay.
Yeah, you get a TS clearance, then you're set.
Oh, when you hit a bump, the
Well, if you
tire's
wanna
still
work
gonna be
with the
spinning.
straight
When
TS,
it lands back on the
We'll just hit you.
ground,
there will always
it's
be
still
a-
spinning.
It just shows you that you're trustworthy enough to get.
And you lost your velocity. So I guess your static friction would be lower.
Yeah, you essentially have like no static friction. Well, your tires not on the air. So okay, now if you have so that's like the car without suspension. When you go over the bump, it's just gonna
Well, I
come
feel like
off
there's
your
ones that
ground.
are. that
You're
you
gonna have
stay in spots.
no grip.
No contact.
And
And
you won't
therefore
see
no
this.
forward force applied.
So
So in that instance in which your tire is spinning in the air, you have no friction and therefore you have no forward force.
I see.
Because it's just spinning in the air for an instant. It's not like a long period. But like if you go over a
And
bump
when you
in that
and when you
instant-
land, because
Where all the
like the
aliens,
tire has to like
Area 51 stuff.
it doesn't just instantly grip, like it's gonna slip for a while, so that's like
Slip,
more
slow
energy
down, and
loss,
then
basically.
once it does get grip again,
Yeah.
go back.
Yeah, so it might skip a bit before fully like going back to spinning with the
And that causes more like hysteresis in the tire, more like heat loss, basically.
Yeah.
Energy loss to heat. Yeah.
So then conversely with suspension, when you hit a bump, your tire hits a bump, what happens?
You maintain more contact and
Yeah.
yeah, and something are y'all familiar with like tire load sensitivity, where like
So
you
does it
get
look like really
the more load on the
I
tire,
mean, yeah.
you're technically okay. Wait, like as you increase load on your tire, you'll increase grip, but it's kind of like a square root where you increase.
Level 7.
you get diminishing returns.
Yeah,
basically.
yeah.
I see.
Okay.
So low sensitivity is just like how quickly that curve diminishes, basically.
Yeah. So then, do you like based on that? Do you want your weight to stay constant as long as possible, or do you want it to like be really peaky, or like it has like a lot of weight on one tire and like low weight on the other tire? Yeah, like roughly the same curve.
I mean, I guess you want it to be distributed, right? Because oh yeah, because if you have like 2 points here versus 1 point here and 1 point here, then the average is your draw line and it's actually lower.
Yeah, yeah. So then if we, okay, yeah. So then kind of going back to like if you're like in the air and then you land on the ground, if you don't have like suspension, there's gonna be some like moment when you land where your tire is gonna have like a lot of force on it.
Yeah, I see.
And like you mentioned, like the
Hysteresis.
yeah, it's gonna kind of like destroy your grip for
Yeah.
a moment of time.
Yeah.
Whereas like if you have a suspension, it will kind of like it'll spread out the amount of time that you're loaded.
Yeah. That makes sense. Cool.
It was like,
Okay. Nice. What do you guys think about our understanding of suspension? Is it good? Is there anything? Are we going in the right direction? Is there like anything you think we should like brush up on?
Yeah, I mean, you guys like it seems like you'll know like it's fun to
I don't know if that's gonna reach, but we'll see.
like they'll know the fundamentals, which is like really good.
Nice.
I think like the hard part, which like I feel like everyone should want is like quantifying it.
Yeah.
Like okay, cool, we know this all. Now how do you actually like implement it on your car? Because
some people are good.
like I mean, if y'all do like in your research, I'm sure y'all have seen it already. Like people like online, you can find like, oh, this is good and this isn't good. And then how do
Yeah.
you define like how much of this is
That was in
good?
his
How much of this is bad?
Yeah. So that was one of my big questions too. Like, how do how did you guys go about
He just
like
probably wasn't as
assigning
good as
like weights, I guess,
the
to
other
each of these like
very
different factors, like spring rate, roll pitch, roll steer?
Yeah.
How did you guys modify it?
Yeah, I think one way to think about it is like for each thing, what are you constrained by? Because like bump steer, for example, you can pretty easily optimize it with no like drawbacks. But then things like weight and other things like that, they're all kind of coupled. Where, like,
Yeah.
oh, you could have like a lighter car at the loss of like some other stuff. For us, it's really like we have like the lap simulator, which kind of helps a lot with that.
It's like literally like Goodwill Hunting.
It's kind of hard to quantify that without it, just because it requires a lot of things that are coupled. But I mean, in y'all's case, I think just kind of like trying to think about it as like as simply as you can. Where like, if you have like this goal in mind,
Oh yeah, I don't think that either. Like, how do you do the
I don't know. This is like the hardest part of like building the car, in my opinion.
Yeah.
Where, like,
do you do two separate stuff?
Wait,
How do you
is lap? Do you guys just use lap sums to like collect data, basically?
kind of. One of like the biggest things we use it for is like, let's say we have like this design idea. You can kind of like give a guess of like how much weight will be added versus like taken away, and then also like, for example, like something for a powertrain.
Yeah.
There is a design where it increased weight, but decreased
That's how you
RCG
cancel
height.
it out. Is I guess you do
So then we used it to compare those
That's
two
the-
cases and see
But
like
why wouldn't that?
which one
why
would
wouldn't that
be
be the
like
case
the
where
high
if
weight
the-
low CG
in
or
the
high
question
CG low weight.
in a home
Wait, the way lap
question,
sum works, like you just input like all those different factors, and then you like
Yeah.
design a track and just simulate like this car like
That's
actually
all the way
driving that track.
Essentially, yeah, it's like you give it like a bunch of points,
Yeah.
like theoretical points.
Well, we have to
It
cancel
connects
out
all of
or
those
not.
points together to make a track, and then it calculates like velocity using like fundamental physics equations at every single point, and like
Oh, okay.
you can find like how much time it would theoretically take that car to go if you did.
I see.
You did a pretty good job.
Okay.
Yeah. There's some like online stuff that's free. I think like Optimus.
Oh, lap sum's not free.
So we or like Sam and Jonathan, they coded it themselves. Well, kind of. Okay, so there's two things that we use. Something. There's this guy online that like has like an open source code for what he did.
So you did so you included all
Oh, there it is. And so we kind of just like copied that and then changed it to work for us. And then there's also like other online stuff that's just free.
So what outputs did you use?
So it was largely okay. It's kind of hard because everything's coupled, so you have to take everything it gives you with a grain of salt.
I see.
But largely like determining which one's more important, CG height or weight. That's like the easiest thing to compare. So that's one, and then camber gain. It kind of gave us that. You can kind of tell it like, okay, if you calculate at every point the amount of suspension travel you have, and you give it like a camber gain, then like it can calculate like how long it would take different cars with different camber gains.
Really?
And then it would tell you like what's your optimal camber gain.
Well, because a few classes reverse scale.
Yeah.
Okay.
That one was kind of weird because it was giving us weird numbers. So I'm taking it with a grain of salt.
Okay.
Code engineers and testing.
It also helped drive a lot of high-level decisions for other systems. Like frame, they wanted to do something where the engine would be part of the frame. It would be like structural. And so one thing we weighed was like the amount of weight you would lose to like the amount of complexity and like kind of riskiness it would be.
Yeah.
That was one thing. Let's just say that idea got shut down. I don't know. I think it doesn't help too much for dynamics as much as it does for like high level vehicle decisions. The main thing that we used for like dynamics was just that Millikan chopper. That's kind of how we decided like all of our motion ratios, our roll sensors, spring rates. Yeah.
So that's the very first thing you do.
It's just
When you start designing, it's like you read the chapter and you use that model to like create like a predicted like you said motion ratio, spring rate,
Yeah.
all that stuff.
Yeah, and I would say you want all of that stuff set before you really start designing the car.
Yeah.
Because that all changes like how everything packages, how
Those drive your design decisions.
And were those do you think it's possible to like choose those if you don't have any like previous
basically
data?
are taking
I think, yeah.
like just even stats,
'cause
basically at the top numbers.
what we kind of ended up doing. Okay, it seems like no one knows how to like pick a number correctly. So what everyone kind of does is just kind of chooses a random number and then changes it based on the previous year. But like, if y'all don't have, I mean, we don't have data. And in our case, kind of, I was thinking we should just
It
like
makes you feel less stupid.
do a reasonable number,
Yeah.
see if it works, change it next year.
That's
So I would say like
So make sure to really collect it this year, like well.
Yeah, and you can just like research like what's kind of common for like solar cars. If you have Aero, if you don't have Aero, just you can just compare a lot of cars that are similar to yours, and use that as like a baseline. And then just using that, you can pretty much
Whereas like if I
just
took
off of that single like number, you can go through the entire spreadsheet there, basically. Yeah.
So you said you guys made like calculators that basically calculate other stuff based on those.
Yeah, so another one of our calculators that Shane made was like, we wanted to calculate what ride height we wanted. And so like a higher ride height would mean like we can do a softer suspension, which
No, it's different.
higher ride
Oh,
height,
oh,
softer.
sorry, yeah, yeah.
And wait, okay, actually let's go.
Well, yeah.
Do you know like
My dad
why
doesn't
softer
say that 'cause he knows
suspension
it was this feature.
versus like a harder suspension is like favorable?
What are the benefits?
Yeah.
Of a softer suspension.
Yeah.
Caleb, you want to
It's a
Hot seat.
So he's like a
It's in relation to kind of the conversation we were having earlier.
engineering was boring.
Yeah. Exactly.
He's like, it was too
And then why is that
No,
favorable?
he was like, once you got out to the work in the world, because you only got one dude
Yeah.
that's tired.
Yeah, exactly.
See, like when you're working,
So
like,
yeah, if you have like softer suspension, then ideally you have a faster car. The drawback to that though is if you have a softer suspension, it's gonna compress more, and that's scary. It's like, what if it hits? Like, what if you go so much that like it scrapes
Yeah.
the aero?
Aero package, or you can bottom out.
Yeah.
And you don't you like roll easy?
Yeah.
Yeah.
And that's bad for tire grip because
Yeah.
then your tire is gonna camber.
Yeah.
So it's all about balancing.
But what I would say is there's so many like factors to consider. I would maybe make a list of like everything that one of your parameters concerns, and then kind of like give a weight or like a rank to them. This one, we kind of did that arbitrarily, and I think like if you try to do it in like a more thoughtful way, you're gonna get like weighed down by like, oh, there's this that we're forgetting, or like this that we're
Because
forgetting.
there's so much.
Yeah.
Yeah.
You can't spend too much time. There's always something.
Especially because like these are the first things you can do before building a car. So if you don't have them done, then you just can't slow the car.
Okay.
But yeah, I would say give like weights to each parameter and then build the car off of that.
What are those parameters? Do you have like the list of them?
I do have a list somewhere. I think at one
High level parameter
Let's just ignore this.
No.
It's kind of there's not really weights to it.
See, this is a bad thing because I feel like this is a say what I do, not do what I do. What I say, not do what I do.
Do as I say, not do.
Whatever. But I mean, for each parameter,
Do as I say, not as I do.
yeah, kind of what I did is I listed like everything it affects. So like track width, for example, longer track width, you can get less weight transfer. Drawback though is it could potentially increase the weight of your car because now you have a larger car. And oh yeah, why is weight transfer bad?
Or like get a lot of cancel.
Do y'all know why? Like why? I guess.
Like lateral load transfer.
Yeah.
It means it's not there.
Wasn't it
You're
really-
probably right. You're probably right.
When we were talking about that earlier,
Yes, yeah.
you, I forgot.
It relates to the
Like it's
picture
not there.
that Leo
There's
had.
no physical motion. Yeah, we're seeing force stack. Force stack being determined the accounting for its physical deformation.
Oh, actually,
Like
I thought I closed that tab.
Oh, I'll handle this again. What's like the most important part of this suspension? Like the most important part, in my opinion, of your car? Tire. Yeah. Because tires are what produce pretty much
Oh, yeah,
everything that relates to your car's.
Yeah, like it's easier for your weight to get concentrated on one tire if you have high lateral load transfer.
And why is that bad?
Because then your overall like grip that you have, I guess, is less.
Yes.
Yeah.
And then slow it down.
What is this called again? Like the diminishing thing?
Tire load sensitivity.
Oh, tire load sensitivity. Yeah, that's right.
So, like, this is one of those cases where it's hard to be like, oh, weight transfer matters this much,
Yeah.
and we can quantify like, oh, if we have a track like this wide, then versus a track that's this small, like quantifying the effects of more weight transfer versus less weight. That's like one of those hard things
I
that
originally did
we
14 first.
don't know how to do. You could maybe do it through lap sim. The only issue is everything's like coupled. So
Yeah.
again, take everything with a grain of salt.
Okay. So you had track width, wheelbase, CG height, ride frequency, roll gradient, roll center, NT squat, and guide.
Are y'all familiar with anti-squat today?
Yeah, just like how much the car pitches when you like accelerate or brake, right? Yeah.
And you can change. It's the same as like roll centers, where
Just horizontal view, side view.
yeah, where you can, based on your hard points, you can change how much it squats or not.
Do you guys have like double like upper and lower control arms? Double wishbone?
Yeah.
That's what's okay.
Yeah. Yeah, I mean, we don't care about anti-squatting as much. Doing hard acceleration. Hopefully.
Yeah, and I'm sure like the design methodology is completely different.
Yeah, that's
Basically, just like most of the stuff in that left column, like your main.
Yeah, and I this was all done like before even CAD was started. Because like we did like it started in summer, but pretty much didn't pull up CAD until
Wait, so what
September.
what do we need to
Until
study?
November we onboarded, and then we finally started CAD.
I see.
So like the spreadsheet, all of these like documents of like what's important to us, what do we care about.
Yeah.
That was all we did for like too long.
July, August, maybe.
Yeah.
Yeah.
Like the spreadsheet.
Stresses.
How many calculators did you
a few.
Which one? Which question?
It's not really.
The second homework?
Suspension stiffness.
Like question 2?
Suspension stiffness.
That's like the Millikan one.
Yeah. So this is like overall like all your inputs,
And then
outputs.
is it like the question 1 on the second?
Those are all
or is it like
equations.
question 0 on the first homework?
Yeah, that one. And then one of our members, he created a calculator for our anti-roll bar system.
I think it's on the same suspension stiffness with hair weakness going on. That
Wait,
would
what
be-
is this one?
That was out.
Not
Oh,
the
that's
first
okay.
one. Did they
I mean,
put the
idea.
second
Point
one?
being,
Yeah.
yeah. So like, you can input different values as to like
The first
what your blade
one,
length
I
is,
did-
how thick are they,
Like I think
things like that, and then kind of
Are you
get.
familiar with anti-roll bars? Other than
Yeah, we don't use them on solar car though.
Yeah, yeah.
And then for the concept questions,
Yeah,
was it
and
really
then that one.
just
So that
like, was it more
one.
like material stuff? There was
This.
actually did it. It was so Millikan has like two types
Really?
of calculations it goes through. The first one's kind of less useful for design, but it's cool to like go through to understand like the math. And then the second one is this one. This is the first.
Yeah.
So it does like the same thing where it's how you would
Number 2 on the
quantify
second one.
this.
And then this is the ride height / pitch this is what we were talking about earlier. So like given like your track wheelbase, or yeah, and then like in different conditions. For instance, like let's say we're static. Okay, we know like a certain ride height, and then like given a certain velocity, and then like your aero parameters, like your CLA, like okay, what's your downforce given your motion ratio? How much does that change your ride height? So then, yeah, so like now your front delta Z with downforce is apparently 22.7 millimeters, given a certain velocity, whatever that
So
is.
it's more like
And
the first
then-
one where.
So like, okay, now we have our ride height after
the one I
downforce,
really
and then
don't
so
understand.
okay, now let's introduce like longitudinal load transfer.
Question for
If like we're accelerating or braking, this is for pitch, right? So then now we have our front deflection or front and rear deflection after that. And you kind of go on, so on and so forth, and then eventually, like, you get your final ride height in front and rear at like the wing and the back of the under tray. Because this was just to see, like, okay, given certain ride heights and like suspension stiffnesses, what is like the what is our like max and min before we start scraping? That's what this is for. And so like that's why it's like, okay, after all of these conditions, what's our final ride height in the front at the wing, or the very front of the wing,
Wait, why did you take it
after
further?
downforce and longitudinal weight transfer with anti-dive, which is another reason why
Oh,
we
yeah,
did this, so we could
absolutely.
like experiment with different anti-dive, anti-squat.
Is it 21 or?
So that one, we have this.
Oh, so did you go out last night? Or did you guys go out?
Actually, I'm
Can't see.
I guess
Where my
you guys are
contacts
probably-
are.
This one was just like, it was just a
Okay.
quick thing. We have like this
Damn,
tire
you guys are
model
built different.
where you can input like a normal load on your tire, and then it can tell you like the amount of lateral force and the amount of longitudinal force at different slip angles and different slip
Okay.
ratios. Do y'all know what slip ratio is?
Oh, bad.
No.
bad.
It's essentially like slip angle, but for like longitudinal force. So like
Oh, really?
your tire, whenever it rotates, it kind of compresses
That is.
longitudinally.
But yeah,
by
no, thank you for
something.
research. I really
And so,
appreciate
just
it.
like slip angle, compressing your tire is like a spring, and it creates a longitudinal force.
Yeah.
So I just think about it as slip angle for the longitude.
Yeah, no, 15 minutes.
So then,
definitely not.
using
'Cause
like
it-
just
when I
weight
was doing
transfer
this homework,
calcs,
it took me forever
which
to
is inside of the Millikan chapter. You can kind of get a guess for like what your tire weight would be at some corner case.
And this is from last year.
But yeah, no.
Oh, no,
If you
no.
have
Or this
for
is-
the
this
rest of
is-
the weekend, though, which one?
Parameters from last year, given
Okay.
this is-
Yeah, I'll see you. Yeah, I'll see you Tuesday. Okay. So,
The entire car would be fun.
yeah, his girlfriend goes to
So all these are from.
So give her like
Yeah.
12
And
yeah,
it
family
walks you through kind of
vacation,
like
which
how to
one
do
is too, but it isn't this one.
really nice. Yeah.
Okay,
And
you said
so
it was
okay, another
this
thing that's
question.
I'm
Or
just
not
I'm just
exact, but like
gonna
similar to this question.
hype this chapter
and
up.
similar to that.
Another thing that's really nice about
This
this
one.
like chapter
Yeah.
is it
Yeah,
if you
that
like
was exactly-
read everything about it, it kind of builds like an intuition of like
I'll
what's
study
important,
those
what's
too,
not.
and, yeah.
So then like if you have like these high level decisions with other systems where like okay how important
I
is
can
this
see
one
the
thing?
second one. This one.
You can kind of like think through like, oh, if we have to sacrifice this for another system, how would that affect the rest of like power dynamics? So how important is your like motion ratio versus packaging something else?
So you figure out like individual parameters of each of these tables. Is there any way like you combine all of them together?
So it's kind of like for like our roll stiffness. Or okay, so like these would be like all of our inputs or like these
So
are all
we
our
do
input
that
parameters.
circle.
And so it's just kind of like a flow chart where like from all of this,
Oh, this one has
from like
information too.
our roll centers, blah blah blah, given like a 1D corner, our ride frequency with a given spin rate would be like this. It doesn't really come together as much as it just kind of like gives you like info about like your stiffnesses. Could you like I guess clarify what you mean by like does it all come together?
Solar X combustion dynamics.
Yeah, you said that there were no ones.
Oh, I guess one way it kind of comes together is like with all of these numbers, we can eventually get like ARB like goal, and then we can use that goal in like the design of an ARB, and like to figure out how much stiffness we want it to produce. Another example would be like from all of these, we can figure out how much spring travel we would expect. So then we fed that into. Or well, we didn't feed it into it, but we used it as like a baseline in like how much we expect the spring to travel, so that we can prevent it from like bottoming out.
Cool. Are there like coupling factors?
Kind of. There's like a lot of the calcs for like your rolls, like how stiff you want your ARB to be for your roll bar. Is dependent on like everything up here. So like I don't know. For example, changing your spring rate changes like everything on your car because everything is dependent on your spring rate.
So you're in Kissick?
I was. Yeah.
Did you go to the state senior year? 2022?
Yeah, I did. I didn't go to nationals. I went to nationals during junior year.
Wait, are you a sophomore right now?
No.
Oh.
Freshman.
Oh, okay. So I guess your junior year state.
Yeah, junior year state.
The one I was at.
Yeah.
Yeah, okay.
Sorry, one of my members asked if I was in the ETC.
He's downstairs right now. I think he's doing scouting.
Okay, so then like after you guys get all these values in the calculator, then you start actually like trying stuff.
Yeah. So like the biggest thing is like our valve cranks, designing our valve cranks to get like whatever motion ratio it tells us about. And then ARB is designing like all of the dimensions to get that specific stiffness. I think figuring out your spring stiffnesses is like the first thing you'll have to do, because if you have like a stiffer spring, then you need like softer ARBs. You need like different motion ratio. So figuring out like what you want your ride frequency to be is like the first thing you'll have to do.
Like the thing that affects the most.
Yeah, set that as a baseline, figure that out, and then do everything.
I see.
One issue we had is we were waiting on Aero for certain numbers before we could set our ride height and like ride frequency. So because of that, we couldn't touch any of our other parameters until we got that. So we were held back for like 2 weeks just because of that.
I see. Yeah. I think that's not as much of a problem for us because like we're not traveling that fast to where like we care about like downforce really.
Yeah.
I think like like for us it's really just like energy efficiency again, like so because we asked Jacob about it yesterday, right? And he was
Yeah,
like,
and Jacob told us we have zero information now.
That's so real.
yeah, on our shocks.
Like, yeah, I don't know. Why did he say we have no information? Because, like, it doesn't. We don't even know the spring constant.
Because we use these like air shocks that are from this that are
Meant for
designed for
mountain bikes.
mountain bikes, and apparently like the manufacturer just doesn't publish any information on like
Well, they
the
have
spring
tested
rate and
ourselves.
like, stuff like that, and like so we have to figure that out. Like,
Do you guys happen to have a rate by any chance to like test and find spring constant?
Not really, but something that you could do is something that
Anything on a pivot? I mean,
Yeah. maybe we have like you could get scales, for example, and then like I don't know how you would rig it up, but like get the shock so that it's like resting on the scale almost, and then shim the shock so that it compresses the spring by some amount, and then you can see how much the weight on the scale increases, and like measure how much your spring like deflected by. So then from that you can do like
yeah.
Yeah, that. Or we can put it, I guess, like you know the setup you had for the example you were showing us?
Yeah.
We can do something like that and see how much force it takes to push.
Yeah.
And I think that should be our next step.
So would you say it was like pretty straightforward? Like once you have all those numbers, you just like just make a geometry that gets this number, and that's pretty much.
Kind of. For at least for us,
Partial critic on
I don't know how packaging is for y'all, but everything was driven by packaging. So like it was really easy getting these numbers. Okay, no, it wasn't really easy.